All right, hello Algebra 2. Today we're going to do our second set of notes on logarithms, and I got it titled 7.4b, More Logarithms. Today we're gonna learn a few more things about them. One thing kind of strange and interesting about logarithms is, well, I can explain one of them one way. Remember that PERT formula that I said was so powerful because it's used for things that grow naturally? Well, it turns out there's a special type of logarithm we're going to learn today that is common because of that formula, because of the usefulness of that formula, and for solving for time on that formula. But anyway, I got a sentence here for you. Logarithms are often used with base 10 or base E. Logarithms are often used with base 10 or base E. So just a reminder, every logarithm that you write has a base to it, because it's related to exponential functions and they have bases. So they're often used with base 10 or base E. Part of the reason it's base 10 is because of like scientific notation and things like that, how oftentimes when you're in science you're dealing with either really tiny things that have lots of zeros in it, or you're dealing with really big things that have lots of zeros at the end because they're really big. So base 10 is pretty common in science. And then I think the default example is using the Richter scale that measures earthquakes. That's actually an exponential application. So anyway, so base 10 or base E. Now, this brings us to our calculators, okay? There are buttons on your calculator to aid in solving these types of logarithms. And the log base 10 is actually called the common log. And like I said, it's log base 10. Remember, you write the base as a subscript. And on your calculator, it's just going to be that log button that stares at you, okay? That's what the button looks like. It'll just say LOG. And it turns out that when you just see LOG with no base written, guess what its actual base is? It's base 10. And then the log base E is actually called the natural log. Nature, you know what I'm saying? And natural log, and that's log base E. And its button should be near the log button on your calculator, but it's LN. Anytime you see LN written, that's actually short for log base E, the natural log, LN. So, just so you get some practice knowing how that button works, let's try a few. Our instructions are to evaluate with a calculator. Log 8. So when it's log 8, it's actually log base 10, and you can punch that in your calculator. Some of your calculators, you'll have to do the 8 first, then the log button. But most of your calculators, you can hit the log button first and then 8, and you should get 0.903. it's pretty common to round logs to 3 decimal places, so that's what we'll do. Let's try another one. ln 0.3. Well, ln actually stands for natural log, but you can just hit the ln button, and I get negative 1.204. Now, I kind of want to mention something real quick. Is it a surprise that the natural log of 0.3 was negative? Well, I would argue that it's not. 0.3 is like a fraction, isn't it? It's like 3/10. Well, e, starts out as around 2.72. To get it to be less than 1 like that, to get it to be a fraction, you're going to have to flip it over. So remember, logs actually ask you what exponent. E to what power gets you 0.3, and sure enough, it was a negative to make it less than 1. So it's kind of a curious thing. Well, let's go on. Log 12. Well, that's the common log. 1.079 is what I get. And let's see, let's put D up here. I don't want to waste another line. Natural log 0.75. Oh, I bet it's going to be negative again. It sure is. Yep. Beep bobble beep. Put it in your calculator. Negative 0.288. Make sure you're rounding appropriately. I should probably do like a mini lesson real quick about rounding, but remember, whatever decimal place you're rounding to, look to the right of it. If the number's 5 or bigger, then you'll round up. If it's less than 5, you'll round down, or leave the same, I guess. And then finally, let's do natural log of 220, and I got 5.394. If you don't have your calculator out, don't be a fool. Get a calculator out. You got to practice this, All right. Sorry, that was a little harsh. Let's see. Okay. Something else that's fancy about logs is what I'm about to present to you here. Interestingly, because log and exponential expressions. Interestingly, because log and exponential expressions are inverses, they undo each other. And you might be thinking, what does that look like? Well, I'm about to show you. So you've got like b to the x, okay? Well, that's an exponential expression. Well, if I go log base b of b to the x, this log base b and that base b with the exponential, they undo each other, and you're just left with an x. It plops down. Isn't that weird? Now, doing it the other way would be you've got a log base b of x, and you want to undo it. This is kind of a curious thing. You make b a base, and you make log base b of x an exponent. Is that not the craziest thing? And when you do that, it undoes it, and you're left with x. All right, so this is funny looking. I'll give you that. But let's practice this a little bit, okay? Let's simplify. And we've got e to the ln natural log of 9. Well, if you don't quite recognize that this is the inverses and they're going to undo each other, you could rewrite this as e to the log base e of 9. And you've got base e right there against each other. They'll undo each other, and your answer is simply 9, just like so. Now it can be a little more complicated than that. You might have log base 3 of 27 to the x. Well, this is a log base 3, and this is 27 as a base. Those don't match, you know. So you might think, well, I guess I'm done. But I want you to think about it a little bit. What if the bases were the same? You know, then you'd be able to simplify this quite a bit. Well, it turns out you can rewrite 27 as 3, you know, base 3 to some power. I believe it's 3 to the 3rd power. So check this out. Rewrite it as log base 3 to the 3rd power, and then you've got an x right there. Well, now the bases are the same. They'll undo each other, and that 3x plops down. It becomes your answer. It's a little bit tricky. I admit. You got to think a little bit. Make those bases the same if possible. But it's pretty cool. 10 exponent log 4. Remember, if the base isn't written, it's actually base 10. They undo each other. Boom. You get a 4. And try this next one on your own. See if you can figure it out. I bet you can. Log base 5 of 25 to the x power. So pause the video if you'd like. Give this a try. All right, you're back. So let's rewrite this as 5 squared and then the x power. 5 squared is 25. But now I've got the bases the same. Log base 5, exponent 5. Okay, so cross it out. You're left with 2x, my friends. All right, how are we feeling? All right, now we're going to get into what I think is one of the more useful qualities of logs. Is we're going to start finding inverses of functions. Okay, we've been tasked with finding inverses of functions previously. Swap the x and the y, and then solve for y. Well, we're going to do the same idea here, and you'll see how logs can come in handy. So I think maybe I'm going to go ahead and move over to the other side here. Our instructions are find the inverse of the function. And let's start out with a pretty straightforward one. Y equals 8 to the x power. I really should be using a pencil. It's bothering me that I'm writing these all in the same color, but I guess not enough to pause and get a pencil. But all right, so what you'll do is to find the inverse, you'll swap x and y. So x equals 8 to the y, but then you got to get y by itself. Well, y is up here in the exponent position. We need to get it down on the ground. Well, we can do what we learned in our previous lesson. We can rewrite this exponential function as a log. And so right now we're in exponential. Our base is 8. Well, we're going to go log base 8 of x equals y. We're doing that circular Tarzan sort of thing. So log base 8 of x equals y. And you want to make sure to write things on the right level. The base 8 is subset, x is on the line, y equals y is on the line. And we did it. We got y by itself. We solved for y. We found the inverse function. that, and then the inverse. Kind of cool. Oh gosh, sorry if you didn't catch all that. Then we got y equals ln x minus 4. What's ln called? It's called the natural log. It's base e, isn't it? If it helps you, go ahead and rewrite it. We need to swap x and y, so we can swap x and y and rewrite it as log base e, if that helps you a little bit. And we need to get to this y. We need to solve for y. Well, I'm going to have to undo this log. So I'm going to rewrite it. I'm going to go base e to the x power equals y minus 4. E to the x power equals y minus 4. Tarzan thing. Oh, okay. Swinging around there. Now we do need to solve for y, so we'll add the 4 over. We get e to the x plus 4 equals y. Man, we are doing some math. It's feeling good. All right, why don't you guys try this next one out? Y equals 6 to the x. Go ahead and try it out. All right, so log, oh, sorry, I'll swap my x and y real quick. Pretty quick. So log base 6 of x equals y. Boom. And then finally, let's do another arrangement here. Mix it up a little bit. Y equals 2 plus log base 7 of x. Swap x and y. We want to get y by itself, but before we deal with that log, why don't we minus that 2 over? Now the only thing left to do is to undo this log, so it'll be 7 to the x minus 2 power. Swings over, picks up that whole thing as an exponent, is equal to y. I don't know about you, but I'm enjoying this log stuff. I hope you are too. You know, it's scary when you first learn it and it seems all weird and stuff, but once you get the hang of it and realize it's related to exponential functions, you know, it's not so bad. It's not so bad. So feel free to rewind the video, rewatch anything you need to. The assignment for this is not a handout. It's page 503 in our lovely textbook. 20 through 44 all. You're going to want to practice this. There you go. Thanks so much.